Hello students, welcome to your software engineering class. In this session, I will discuss about testing. In the previous session, I have discussed about coding phase, and after coding and code review, the software engineer tests the software. In testing phase, there are many type of tests, and after the testing phase, the software is ready to release to the market or for the customer. So in this video class, I will discuss about testing and difference between verification test and validation test, and how to design a test suite. So let's start. Contents of this video are introduction to testing, program testing, some commonly used terms associated with testing, verification and validation, validation, design of test cases, and testing approaches. Introduction to testing. Testing is the process of executing a program with the intention of finding errors. Means it is a process to find the bugs. However, for most practical system, even after satisfactorily carrying out the testing phase, it is not possible to guarantee that the software is error-free because of the fact that the input data domain of most software product is very large. It is not practical to test the software exhaustively with respect to each value that the input data may assume. Means after testing phase, also after successfully completion of testing, we cannot guarantee that the software is error free because the input data domain is very large for any software. Means the test cases or test domain is very large, and practically it is impossible to test every case. So we cannot guarantee, the programmer cannot guarantee that the software is error free, and finding error is most difficult task in the software development phase. It takes most effort to find the errors. Testing a program consists of providing the program with a set of test input or test case and observing if the program behaves as expected. If the program fails to behave as expected, then the condition under which failure occur are noted for later debugging and correction. Means in test case, the testing team or the programmer design some test cases and observe the output of the program. If the output is as desired, then it's okay. If it doesn't give the expected result, means it has some error, and the condition under which the error is occur are noted, and later on it debug and corrected to make the error free or to clear the error. Next is some commonly used term associated with testing. First is failure. This is a manifestation of an error or defect or bugs, but the mere presence of an error may not necessarily lead a failure. Failure means there must be an error, okay, but presence of error means not a failure. Error can be rectified. And next is test case. This is the triplet. Test case always consists of three values, so it is known as triplet: I, S and O. I is the data input to the system and S is the state of the system at which the data is input, and O is the expected output of the system. Means the test case always consists with three value I, S and O. I is the input to the system, S is the state of the system and O is the expected output. Then the next term is test suite. This is the set of test cases with which a given software product is to be tested. Means all the combination of test cases is known as test suite. These are commonly used terms associated with testing phase. The next is verification and validation. Verification is the process of determining whether the output of one phase of software development conform to that of the previous phase, whereas validation is the process of determining whether a fully developed system conform to its requirement specification. Thus, while verification is concerned with phase containment error, the aim of validation is that the final product to be error free. Means verification is concerned with the phase. In each phase when we check the error, okay, that is known as phase containment error. Earlier finding an error is known as phase containment error. Verification is concerned with phase, and validation means when we are checking a fully developed product with the software requirement, with the requirement of the user. We validate the software, the fully developed product, when check with the SRS, check the validity and check the requirement of the user. The software is fulfilling the requirement of the user or not. That is known as validation. Validation is checking of fully developed software, and verification means checking at each phase level, in the phase level of the software. Okay, next is verification. Verification is the process of confirming the software is meeting the business requirement and is developed adhering to the proper specification and methodology. Verification ensure the product being developed is according to the design specification. Means verification check according to the design specification, and verification answer the question, are we developing this product by firmly following all the design specification as written in the design specification. We check the things to verification is for checking that the software is following the design specification or not. Verification concentrate on the design and system specification, because verification is checking at the phase level. Then validation. Validation is process of examining whether or not the software satisfy the user requirement. It is carried out at the end of the SDLC. If the software matches requirement for which it was made, it is validated. Validation means checking a software, fully developed software, each matches the requirement for which it is developed. Means it check the user requirement are satisfied or not. Okay, after the software is fully developed, then the software is known as validated. Okay, validation ensure the product under development is as per the user requirement. Validation answer the question, are we developing the product which attempt all the user needs from this software. Means it check that the software is fulfilling all the requirement of the user or not. Okay. Validation emphasize on the user requirement. Validation check the user requirement, okay, on the fully developed software, but verification concern with its design specification and check at the end of every phase. Then the next is design of test cases. The number of random test cases in a test suite is in general not an indication of the effectiveness of the testing. Means in generally or in randomly, if you design the test case, then it will not affect, we cannot find error. In other words, testing a system using a large collection of test cases that are selected at randomly doesn't guarantee that all or even most of the error in the system will be uncovered. Means by randomly selected test cases cannot discover all the bugs, cannot discover all the error from the program. So we have to design very carefully the test cases so that we can discover all the bugs. A good test case is one that has a high probability of detecting an undiscovered defect, not one that so that the program work correctly. Means good test cases always discover error, not that it so that it working properly. Okay, we must design an optimal test suite that is for reasonable size and can uncover as many error existing in the system. Means we must design a test suite that is optimal, that can uncover the error, okay, so that the software become error free. So we have to design the test case carefully that it can discover the error or bugs. So this is an example. This code segment has a simple programming error. If x is greater than y, then max is x, else max equal to x. Here this is error. Here the programmer should write else max equal to y. So here is the error. So we have to design test case carefully. The first test suite, x equal to 3, y equal to 2, means it will check 3 is greater than 2 and max equal to x means max equal to 3, means it will generate the correct output. But the next test case like x equal to 2 and y equal to 3, here the condition 2 is greater than 3, the condition is false. Here the output will show max equal to 2. In the else case max equal to x, so it will show max equal to 2, which is the wrong answer. So in this case it can detect error. So this is a good test cases. Whereas the large test suite, x equal to 3, y equal to 2, then x equal to 4, y equal to 3, x equal to 5, y equal to 1. Here in all the cases the x is greater, so it doesn't detect any error. So we have carefully designed the test case so that it can detect error from the program. The test suite should be carefully designed than picked randomly. Therefore, systematic approach should be followed to design an optimal test suite. in an optimal test suite, each test case is designed to detect different error. Means we cannot select the test case randomly. So we have to follow a systematic approach to design the optimal test suite so that it can discover all the error from the program. Test can be conducted based on two approaches. Okay, these are the testing approaches. First one is functionality testing and second one is implementation testing. When functionality is being tested without taking the actual implementation is concern, it is known as black box testing. In black box testing, it always emphasizes on functions. Means in this case it gives the input and observe the output. It doesn't bother about the working. Test cases are designed using only the functional specification of the software without any knowledge of the internal structure of software. It only emphasizes functionality of the procedure. It doesn't concern about the internal structure, and it is known as black box testing. Actually, we will discuss about black box testing in other video. Detailedly, we will discuss all the method of black box testing. Then the next testing approach is white box testing. The other side is known as white box testing, where not only the functionality is tested but the way it is implemented is also analyzed. In this testing we analyze all the things. Functionality is tested, on implementation is also tested. So white box test case require a thorough knowledge of internal structure of software. Okay, means in white box it tested all the things of the software. So these are two types of testing approach. First one is black box testing and second one is white box testing. Black box test only the functionality, but white box tested functionality as well as the implementation. Okay. So this is all about your testing and what is the difference between verification and validation and the testing approaches. And the next class I will discuss about unit testing. Thank you.